Okay, perimeter, area and volume. So, this is looking at using things such as aerial photographs to find distances. So when we've got, the most common one being Google Earth, it's quicker than actually measuring the land. Who wants to go out there and actually do all that work when you can utilize other things at your fingertips? Okay, so here you've got an aerial view, shows a 50-metre swimming pool. So what is the scale used on the image? What you're going to have to do, so I do apologise that I don't have this on me, but so because we know that the length of the pool here is 50 metres, you're going to measure that with a ruler where that little arrow is, that's in black, and you may be best off using that in millimetres. So, for question A, whatever you measure it in millimetres, is equal to 50 metres. If you're going from millimetres to metres, you need to times by 1,000. So it's 50,000 millimetres. And then remember, you might be able to simplify that. Okay, so you can actually take it down and measure what it actually is on paper. Then whatever that scale is, because you might want to find out what just 1 millimetre is. Because if you find out what 1 millimetre is, then you can use that scale to find the boat in metres. When I've done this previously, obviously, I've measured that to be 2.5 centimetres. So I'll just use that for the sake of B. 2.5 centimetres, we know, is 25 millimetres. Okay, so you need to then use the scale you found in A to go back. If you're having a little bit of trouble with the scale, then go to your textbook in the OneNote and have a look at the step-by-step instructions, or ask your teacher. So this is an example, it's example 16, and it's 1I. So that should help you go a little bit further. Their measurements may not be exactly the same as ours, okay? But it's the concept that will remain. So then area, divide the area into square grids. That's an estimate, and we can use formulas and dimensions according to the scale. So you've got a warehouse shown on Google Earth. There's actually a scale here. The red scale bar represents 42 metres. So, not sure if this will record for you, but I'm just double checking. What we've got here as I forgot to print it. So here's one I prepared earlier on. Sorry, you can skip forward if you need. Oh, here we go. So, the scale bar is 1.2 centimetres. Okay, so this here measures 1.2 centimetres. And I think it's actually got a little point here in red. Okay, so we've got calculate the dimensions of the length. So we've got the scale, whoops, 1.2 centimetres equals 42 metres. So therefore, 1 centimetre equals 35 metres. If you're not sure how I determined that, divide by 1.2. Whoops. Divide by 1.2. Calculate the area of the land measured by the warehouse. So, what you can do then is we've got some different shapes here. We've got A, B, C. You could do up to and make G there, and you've got a rectangle. So you can multiply this side by this side. You then have a trapezium. You can find the area of that. You then have a triangle. Find the area. Oh, we don't even need that if I've used the trapezium. Okay? So, or the other thing you can do, find, actually this is going to be easier, A, B, D, F. Okay? So AF equals, it measures at 2.5 centimetres. Okay? AB is 4.2 centimetres. So that will give you the entire thing. When we want to find the area of the triangle, we just need ED and DC. So, ED, whoops, is 1 centimetre, and DC is 1.3. So to find out what those measurements are, according to our scale here, we're going to multiply each of them by by 35. Okay? So to find the actual, times by 35, times by 35, so we've got 87.5. .2 times 35 is 147 metres. obviously 1 times 35 is 35 meters, but I wonder how many of you actually looked at trying to do that on your calculator. And 1.3 times 35 is 45.5. So 45.5 meters. So the reason I'm actually doing that is because we need to find the area of the rectangle, subtract the triangle, to find the area occupied by the warehouse of the building. So that's what we're going to do here. Area of building. So A equals 87.5 times 147. $12,862.5 meters squared. Area of a triangle. So the missing land. Technology. You gotta love it. Half the base times the height. Formula for area. So, or area of a triangle. Half times the base times the height. 45.5. So 0.5 times 35 times 45.5 is 796.25. So the area of the warehouse, 12,862.5 meters plus 796.25 equals, and let's see how good my maths is, 8, 15, 16. Ooh. Oh, good one. If you hadn't already noticed, you're probably thinking, why is she adding them? What an idiot. Yeah, I know. I should have subtracted. So, 12,862.5 minus 796.25. So, and I've rounded right at the end. Don't round your numbers beforehand. So now we move on to volume of water. We use the formula volume equals area of the base times the height. Now for bodies of land, irregular bodies of land like lakes, ponds, whatever, we use what's called the trapezoidal rule. So A is the area the water covers, H is the body of water. There's two different ways of seeing it, so I've done both for you. So, h on 2, that's the height, distance of the first times distance of the last. So, you've probably seen area of a trapezium, h on 2 outside of a plus b. Very similar to that. So if you have a look at this, they use W here, so you don't confuse H here. Okay, so to find the area of this base, you must calculate that. That's your irregular body of land. Then area of the base times by the height. Only applies when there's uniform thickness though. Okay, so sometimes people can have a really wonky shaped pool. So we've got the shape of water in a pool. So this is the exact same diagram as above. We've just got some measurements. Apply the trapezoidal rule for the area to approximate the volume of water. So we're going to use this here. That's our base. Okay, so area of the base. So h on 2, I'm saying h because that's what you have on your formula sheet. 8 on 2 outside of 6 plus 1.5. 8 on 2 is 4 times 6 plus 1.5 is 7.5. And yes, I'm cheating. 30. And you've already noticed my mistake. Is that there? Is that there? So I should have used 4. So 6 plus 4. That's nicer, which is 10. 4 times 10, 40 meters squared. Question then says to approximate the volume. So, volume equals area of the base times the height. We just found the area of the base to be 40 times the height this time. This is where I use 1.5. And we've got 60 meters cubed. Okay? 100 millimeters of rain falls on the pool. Assume it has vertical walls that extend vertically above the surface, so no water runs out of the pool, and the depth doesn't vary. By how much does the volume of water increase? So if you have no idea where to start, so it's saying its current volume is 60 meters cubed, but we get some rain. Okay? What you notice about the rain, it's in millimeters, but our volume and our area, where everything else is measured in meters. So 100 millimeters of rain equals, if you're not sure what to do, so millimeters to centimeters, divide by 10, and then divide by 100. So 1, 2, 3, so we've got 0.1 meters. So that is the height. Okay? We've got the area of the base. It's still 40. So volume equals 40 times 0.1. That is taking into account the rain that's just fallen. And that's 4 meters cubed. So how much does the volume of water in the pool increase? Gets an extra 4 cubic meters there. You can also look at this on Maths Online, ask one of the other maths teachers, or look over in your textbook. Okay, I know that's a big lesson, but there was a lot to cover. Good work, guys. Thanks.